Okay, so in this particular video, we're still talking about absolute value, but this time instead of equations, we're talking about inequalities. Now, there's a few more rules here, so if you need to rewind a few times and make sure you get all the rules down, very important, okay? So, again, we'll do this example by algebra, but then I'll show you also in the next video how to do it by graphing, okay? So, make sure you know both techniques. All right, first off, when we're talking about absolute value inequality, we have two rules. Pretty much if you have a less than sign, we're going to split this up into an and problem. So you might want to say something, just making some notes, less than, and that also includes the less than or equal to, but if you see that less than sign, then we're going to go and. Which means, if you remember the previous videos when we talked about a compound inequality, the variable is going to be in the middle. Then, if we have a greater than sign, or greater than or equal to sign, it's going to be an or problem. So what we want to do is say greater than is an or problem. Okay? So let's go ahead and do this example. In this particular problem, I have the absolute value of 2x plus 7 is less than 11. So less than kind of sounds like and, so it's an and problem. And problems are pretty easy. What we're going to do is put our absolute value piece in the middle, so 2x plus 7. And then we're going to put our inequality symbols, same type of symbol that we have on both sides, keep it in the same direction. And then on the left-hand side, we put negative, in this case 11. And on the right-hand side, we just keep it positive. We've made our compound inequality, that's an and problem. If you remember the video when we talked about compound inequalities, the next step is to split it up into two separate inequalities. So there's one of them. Here's the other. Let's just go ahead and write those out. So I have 2x plus 7 is less than 11. And negative 11 is less than 2x plus 7. Okay, so what we're going to do now is solve each one of these inequalities individually. Then we're going to graph them together on the same number line. So our first step to solve the green inequality is to subtract 7 from both sides. So we have 2x is bigger than or equal to negative 18. Then we need to divide by 2 on both sides to get x by itself. So x is bigger than negative 9. That's our first inequality. For our other inequality, what we're going to do now is our first step is to subtract 7. So we end up with 2x is smaller than 11 minus 7 is 4. Okay, so 2x is smaller than 4. We need to divide by 2 on both sides to get x by itself. So x is less than 2. Done with that inequality. Okay, so I'm done with my scratch work. Now to actually graph out my solutions, just like we did in an earlier video. We're going to put them both on the same number line. I like to put 0 in the middle, just kind of give me some kind of orientation. To the right is going to be positive numbers, to the left is going to be negative numbers. All right, so obviously negative 9 is somewhere over here. And based on the inequality symbol, there's no line under it, so I'm going to need an open circle at negative 9. Positive 2 is going to be somewhere to the right of 0. Based on the inequality symbol, I'm going to need an open circle there. And again, it's an and problem, so once I graph these two inequalities together, I want to be sure that I'm looking at the overlap. So, let's solve the inequalities. So, I want x is bigger than negative 9. Again, I like to use 0 if I can for my test point. 0 bigger than negative 9. That makes sense, that works. So, everything to the right is also going to work. Alright, now I'm looking for all numbers where x is smaller than 2. Again, use 0 for your test point. 0 is less than 2. That obviously makes sense, so everything to the left of 2 is going to also work. Okay, again, all I need now is to graph.
Will the following students please come to the cafeteria at this time? Again, the following
And that's
students
it.
please come to the cafeteria.
Okay, we're looking for where the intersection is.
Francisco Ramirez, Tiffany Parker, Nick
Just wait
Flake,
for these announcements to
David
finish.
Valdez, Megan Little, Sierra Suarez, Ashley Payne, Crawford Boland, Takia Sanders, Blake Honeycutt, Laney Franklin, Kashawn Bryce, Deshaun Johnson, Caleb Brown, Emily Meeks, Tyler Owens, Zach Cook, Victoria Beam, Courtney Wisnett, Emily Day, Christopher Skidmore, Marcus Boulon, and Costella Tyler. If those students will please come to the cafeteria at this time.
Okay. Sorry about the interruption. Sometimes that happens. We just get over it. So anyways, what I said is we're looking for on our graph where the point of intersection is, and that's in red, and that's the only part of this graph that we care about. Okay? Now, in this particular example, what we have is a greater than problem. It's greater than or equal to problem. So again, our rule at the beginning of this video says that's an or problem. And what we're going to do is split this up into two separate problems. So we have 2x plus 7 is greater than or equal to 11. We're going to keep that one exactly the same, no big deal. And 2x plus 7 is less than or equal to, notice we flip the symbol when we do this, so or is a little bit trickier. So less than or equal to negative 11. If you want to know why we have to flip this inequality symbol, come see me individually. Otherwise, just make sure you do this. Otherwise, if you keep the inequality symbol in the same direction, it's not going to come out right. Just trust me. All right? So now what we want to do, this is the four problem, we want to solve them individually. So minus 7 both sides. So 2x is greater than or equal to 4. Or minus 7 on both sides. 2x is less than or equal to negative 18. Okay, and now we're going to get x by itself on both sides by dividing by 2. So x is greater than or equal to 2. That's one of my solutions. And divided by 2 for the other inequality as well. So x is less than or equal to negative 9. Okay, so again, for this particular problem, it's an or problem, so I don't care at all about the overlap. I'm just going to graph it as is. Start off with a sketch of my number line. That's a 0. So here's positive 2. Based on the inequality symbol, I need a closed circle. Here's negative 9, somewhere over here. Based on the inequality symbol, I need a closed circle. And we're ready to start graphing again. So I'm looking at using 0 as my test point. 0 is not bigger than 2, so 0 is to the left of 2, so that means, that kind of implies that since 0 is to the left and it didn't work, that must mean that everything to the right will work. So here's that part of the answer. And then, again, I'm going to use 0. 0 is less than or equal to negative 9. Well, that doesn't make sense at all. 0 is to the right of negative 9, so it didn't work there, to the right. So what that implies is everything to the left will work. So everything to the left will work, and that's our graph. Take some time, especially with this algebra, make sure you know the rules for solving these algebraic absolute value inequalities. Again, in the next video, I'll show you how to do this by graphing. Use whatever method you like best, but be sure you know how to do both, just in case.